I'm Lance Hosey. I'm thrilled to be on the stage with my friends Bob Harris, Andrea Love, and James Timberlake. You're going to hear from each of us about this theme of consilience. This year marks the 20th anniversary of E.O. Wilson's book by that title, in which he argues that humanity's relationship with the earth will remain problematic until we bridge the divide between the arts and the sciences. And we're here to argue that that is no more urgent. It's urgent in no field more so than in design. That's a terribly constructed sentence. So in the modern era, we think of art and science as completely different things like oil and water. One is subjective, the other one's objective, one is creative, one is analytical, etc. And this is a modern conceit that goes back to maybe Descartes. The ancients, Aristotle didn't see the arts and sciences that way. A few years ago, I wrote an article arguing that architecture should not be thought of as art because art is sort of an elusive term, but the popular conception of it that is that it's first and foremost about self-expression. And when architects think of architecture first and foremost as self-expression, that's when we get in trouble. The backlash to this was pretty severe. Design journalists I really respect posted in social media. They thought this was claptrap. Someone wrote a blog post about this, calling it an evil concept. So the idea that architecture as art is so firmly ingrained in our culture that the minute we suggest that maybe we could question that, there's a pretty tremendous backlash. A friend of mine who's in the audience, and I won't point her out, but she's sitting on the bride's side, asked, well, if architecture isn't art, what is it? And I said something like, well, why do we have to compare it to other fields? But if we are going to compare it to other fields, what would happen if we thought of it first and foremost as a science and not an art? We're sitting on stage with Andrea, who is a building scientist, so I'm hoping I'm sucking up to you a little bit by saying that. So there's more and more evidence that the built environment has a significant impact on the triple bottom line. People spend most of their time indoors. The very little time that they don't spend indoors, they tend to be in cities surrounded by buildings. Over the last 5 years or so, for the first time in human history, more people live in cities than don't. Architecture is a backdrop of society. Depending on which source you look at, the built environment accounts for close to 40% of annual global GDP. So there's a significant economic impact of the built environment, and yet architects, by and large, are not well trained to understand economics. And finally, you wouldn't be a green build if you didn't know this stat, that nearly half of greenhouse gas emissions every year is due to the built environment. So you can't really address the challenge of climate change without addressing the built environment. So I wrote my book, The Shape of Green, which came out in 2012, to address this question. And as far as I know, it's the first book to study the aesthetics of sustainable design and ask really what that means. And the basic question that the book asks is, does sustainability change the face of design or only its content? Conventional wisdom about this is pretty clear. Some of the most famous architects alive have dismissed the whole agenda by claiming that it has nothing to do with architecture. Raphael Vignoli, who was my first employer out of grad school, says that sustainability has or should have no relationship with style, meaning that inevitably we should avoid sustainability influencing what a building looks like. And then finally, the American Prospect magazine asked whether well-designed green architecture is an oxymoron, meaning that embracing the principles of sustainability doesn't just occasionally lead to ugliness, it inevitably leads to ugliness, right? Now, as more and more people embrace this agenda, we're seeing better and better projects in terms of aesthetics. So a good example of that is about a decade ago, this house in Australia made the rounds, was on the cover of several books as being a great example of what was then being called good green architecture. I wrote the introduction to the book on the right there, so I'm a little bit responsible for what I'm about to say. So, and it is true that, I think architects look at this house and probably think that it looks good. It also performs pretty well because it has some pretty smart systems, but what makes it look good has nothing to do with what makes it work well. In fact, arguably what makes it look good, all that glass, which appeals to architects, undermines its ability to perform well. So even in those cases where something looks good and performs well, the standards that drive those two things are still separate. The art of architecture and the science of sustainability are like oil and water. This looks like the Farnsworth house, and we don't think of Mies van der Rohe as being particularly green, right? So around the same time, 2010, Vanity Fair put out a survey of, I think it was 53 leading architects. If you think about the 50 architects most famous today, they all participated in this. And they asked them what the most important buildings were since the year 1980. And by far, the top of the list was Gary's Bilbao. Now, the list, there was a number of people, including me, published articles pointing out that there was a conspicuous lack of exemplary green buildings on this list, which suggested that the architectural elite was not interested in sustainability. I called this the A list. In my then column in Architect magazine, I did an alternative study, a survey of 53 leading green building experts, some of them are in the room, and asked what the most important green buildings were from since 1980, and the contrast between the two lists is pretty dramatic. There's not a single building on either list. There's not a single American architect who appeared on both lists. The two architects who did appear on both lists, Piano and Foster, their buildings that were on the A list were much older and not particularly known for performance. So what this suggested 8 years ago was that standards of good design and standards of green design are completely separate. So in my book, the way that I describe ways to bridge that gap is I sort of divide the book into 3 principles or 3 kinds of shape: conservation, attraction, and connection. I'm going to go through the first one a little bit and then just touch on the last 2 in the interest of time. So on the one hand, we have this, I think it's good news that the whole industry over the last decade or 10 or 15 years has moved towards having more in-house intelligence to try to address performance in buildings. But we still think of performance as something that lives in a BIM model or in a technical manual and not something that lives on a napkin sketch. But the research all says that up to 90% of the eventual impact of a building is determined in the very earliest design decisions. It's the stuff that does appear on the napkin sketch. But the way we tend to design is we design things that we think looks good, and then we invite people, smart people in, mechanical engineers, building scientists, to try to make it smarter through systems. And a smart building scientist will tell you, well, if you made stupid mistakes at the napkin sketch level, most of my job on this project is going to be to make up for those mistakes. There are simple rules of thumb for different kinds of projects in different climates around sun, wind, and proportions, ratio of surface to volume. By and large, my impression is that most designers are not aware of these rules of thumb. A pretty good, very recent example of the power of these rules of thumb is that I'm working on a student housing project in California, and the master plan for this site for the whole campus called for this building to have all the rooms facing east and west, which I think we all know intuitively is a no-no. It makes things hotter, there's more heat gain, more energy. Just by rotating it so that everything's facing north and south, we have significant reduction in heat gain, in energy, and also improvement in comfort. So we organized the whole building around these courtyards to create these social spaces that are heavily vegetated and induce airflow and movement and sight lines. So I call this sort of thing self-sustaining form. And we, over the last decade or two, designers suddenly have the tools to be able to create more and more specific forms. But by and large, we've been using those tools as a means of self-expression. We get to ever and ever greater exotic geometry without actually using the power of those tools to solve problems. A really simple example of what I'm talking about to try to get to use them to solve problems is Lakeland put out a series of pots and pans recently where you wouldn't think that boiling water is a task that we can improve all that much, but just by adding these nodules on the outside of the surface, they sped up the heating process by 40%, which is a significant savings. So what it looks like and how it works are essentially one and the same. Having my Marco Rubio moment with coffee. So the architectural equivalent of that is Mark West at University of Manitoba. He and his students have been experimenting with fabric formwork for years. Formwork for concrete usually is plywood or fiberglass or something, so you build little boxes out of that, you pour the concrete in, it sets, you take off the box, and what's left over is box-shaped concrete. So, and in fact, virtually every building you've ever been in, the structure would either be concrete, steel, or wood, and all of those things are designed for the worst case scenario. So a beam, say it has to be yay deep at the midpoint of its span, then we extrude that section all the way across that. So you've got probably twice as much material than you need in every structure and every building you've ever been in. The fabric formwork allows them to sew the formwork like a dress and put concrete only where it's needed, so it looks like a three-dimensional moment diagram. Raise your hand if you're an architect. So when I say the phrase moment diagram to a room full of architects, I see these Pavlovian responses of fear, because, well, remember, late nights was structures. So it saves about half the amount of concrete, and it also creates this incredibly supple-looking dolphin-like form that I think is incredibly beautiful. So if you applied that same level of ingenuity to all the basic components of buildings, columns, beams, doors, windows, walls, roofs, etc., would buildings evolve to become more like skeletons or reeds on a riverbed or a forest and less like boxes and cages? So when we talk about the relationship between form and performance, by and large, the most celebrated architecture is solidly at one end of this spectrum, compelling form without compelling performance. Most of the most famous architects that we've heard of practice heavily in this range. You get to exotic geometry, and in fact, the exotic geometry is not only not solving problems often, it's creating problems. There's more and more evidence about how the most expensive coveted commissions are, frying cars in the street and cost overruns, leaky roofs. The other end of the spectrum are buildings that have compelling performance and not particularly compelling form. It's these kinds of buildings that might get to net zero or LEED platinum, but aren't terribly compelling as an experience that lead people like Eisenman and Vignoli to dismiss the whole agenda. In that sweet spot in the middle, there's relatively few examples. Some of Foster's work does it. The London City Hall leans into the sun, so it's self-shading. It reduces the profile on the hottest times of day. It's transparent on the north, not as transparent on the south, etc. And as a result, it uses about 25% of the energy of a typical office building in Europe. Saarbrück-Hutton's Bank Tower in Frankfurt has a west-facing site, which is difficult. So above the retail podium, this airfoil-like, wing-like shape rises up out of that, which does two things. Minimizes the profile of the form on the hottest side of the building, the southwest, and also induces airflow across the building because it's an aerodynamic shape to try to induce greater passive ventilation. I worked on a project for a super tall building on the Azure coast of China, and we were looking at similar sorts of things. I had just come back from the Sonora Desert and saw the saguaro cacti, and it got me really jazzed about that as a model for buildings. And then what's interesting about these structures is that the sort of folding in the surface does several things at once. It's self-shading, so you can see just in that one photograph that as much of the surface of the cactus is in shadow as it is in light. It also stabilizes the structure, so it allows it to grow taller. And as it gets drier or wetter, it expands and contracts like an accordion. So when you use this as a model for a tall building, the taller you go, wind loads are the determining factor of the form of a skyscraper. And on the bottom right, you can see that the traditional way of doing this with a rectangular footprint is to heavy up the structure. So try to resist the wind load with more material. If you create more of an airfoil or an aerodynamic shape, you can avoid that and reduce the wind load. But if it's too aerodynamic, it speeds up the wind, which is a problem. So it turns out that these nodules in the surface of the building sort of regulated the airflow in a way that made it work really well. And then the form is shaped so that it reduces the heat gain on the hottest side of the building, but also in these sort of nodules in the surface, the parts that were in shade were where the glazing was, and the parts that were exposed to light are where we had building integrated PVs. This year I joined Gensler as a design director. This project is in my book, The Shanghai Tower, and because of the torquing of the structure for these same issues, wind loads, we could save about 25% in the steel by working with the wind instead of against it, and about $60 million in structural costs. The other two principles in my book I'll just touch on very briefly. There's an emerging wealth of research in neuroscience and environmental psychology around shape, color, pattern, texture, form, space, about the human response to that. And we're finding more and more that there's a fairly universal response to these kinds of things. This is the Designers Toolkit, meaning we understand by and large how people are going to respond to certain kinds of things. There's a lot of great research into fractals, for instance, and they tend to reduce stress. But most designers I've met aren't familiar with this research, and the ones who are trying to incorporate it in fairly heavy-handed ways. What would happen if we embrace this so that when we make a color choice, it's less about what we subjectively like as designers and more about what the research says about the impact that it has? And then finally, connection, designing for a specific place. Architects like to blast McDonald's for building the same building everywhere, and then we give awards to Frank Gehry for doing the same thing. So that's my standard line. I'm sorry if Frank Gehry's in the audience. And another way of putting this is that arguably one of the most coveted aspects of design is the so-called signature style. In fact, James and I were talking about this at dinner last night, that architects who don't have a consistent architectural vocabulary are seen to be sort of lost, or they haven't found their voice, or they're not mature. And some architects, such as Eero Saarinen, were criticized for having a diversity of responses to different places. And I'd like to say that, so on the one hand, the culture of design covets this. On the other hand, it's arguably the single biggest deterrent to sustainable performance. And that if you understand in advance what something is going to look and feel like, you disallow it to evolve to become whatever it needs to become to serve those people in that place. If you look at the traditions of vernacular and indigenous building patterns, they're the opposite of what modern architecture teaches, in that form does not follow a function. A Virginia dog trot and a New England colonial have the same exact function, single-family house, but they are completely opposite in form. One, the operative condition is it gets really cold in winter, so the ratio of surface to volume is really compact, small windows, hearth in the middle. Virginia dog trot is spread out and low, big hole in the middle to induce breezes because it gets hot and muggy in summer, right? These are really simple ideas that we've known for generations and generations, but we sort of lost sight of this because of air conditioning. Some of the work you're about to see, I think, is some of the most sensitive work being done today in terms of how you adapt buildings to place. So I'll end on this. So I mentioned that not quite a decade ago, this G-list study that I put together suggested that standards of good design and green design were completely separate. There is evidence that that's improving. A couple years ago, I revisited this by looking at, raise your hand if you're familiar with the Code Top 10 Award from AIA. So until January, I was on the Code Advisory Group, and we did a couple of studies over the last few years looking at the first 2 decades of top 10 winners, thinking, well, there's 200 projects that represent the evolving leading edge of sustainable design. What can we learn from that? And one of the things we did is we compared projects that had won top 10 awards to projects that had won National Honor Awards. So one is sort of the pinnacle of sustainable performance, the other is the pinnacle of design and aesthetics according to the design community. What we found is that at that time, only 13 projects had ever done this. 2 of them were done by Lake Vlado, and I'm hoping Bob will show you some of those. Brooks Scarpa has done 3. Those are the only 2 firms that have ever done this twice. So, and I think there are 20,000 architecture firms in the U.S., and only 2 of them have ever produced work that the industry has decided represents the pinnacle of both of these things. Those 13 at the time represented about 6% of all the eligible projects that could represent the cream of the crop for both sustainability and design. Fast forward to today, there's 17, so we've gone up a couple of points. And in fact, over the past 2 years, a quarter of the projects that have ever done this, one of them was by Payette. I think Andrea is going to show you the Milken Institute in a minute. And over the past decade, 2/3 of this. So what that suggests is that, yes, relatively few, a fraction of the eligible projects have actually represented the intersection of good design and green design according to industry standards, but it seems as if the rate of that is accelerating. So I'm wondering if we're tilting closer and closer to consilience. Thank you.
Good morning. I'm wondering how many people here are not architects? Wow, okay, great. Welcome. We're not so scary, and we do mean well. So glad to have you here with us. Kira especially is not scary, but fun to be around all the time. I'm going to talk to you about two projects that I think speak to part of what Lance is saying and do this a small way in trying to think about how to bring the sciences together with the humanities and with people and nature and creating consilience around that. The first one is a project that in fact, both these projects are recently completed, but this one in Ocean Springs, Mississippi. It's the replacement for a nature center museum type space in Biloxi. Think 30,000 square foot box, 3 feet above sea level, completely destroyed. And we've been working with FEMA over the course of the last several years to create a new sort of solution for them. They had a site near their existing research lab at this interesting place that happens to be one of the highest pieces of ground in the entire area near Ocean Springs. It's 19 feet above sea level. It sits next to this protected bay inlet that allows their boats to go out to the open water. And it is adjacent to a tremendous amount of green space that is virtually untouched. So one of the things I want to emphasize today with you guys is to think about the idea of the confluence between geography and ecology and place. And I know that place is not a hard science like you might think of some of the others, but it is every bit as much important and goes with those other two elements in a way that is undeniable. And it always starts with a clear and distinct understanding of the site. For this project, we started with an exploration with an ecologist that you see there digging in the dirt and talking to us about soil profile. We're learning about drainage and the ecological systems that exist here, about the sort of systems that are resilient and sustainable because of that. And so only from that basis can we start to understand the site. Next step, thinking about the resilience of this site, thinking about the buildability and sort of responsibility here, an evaluation of the high ground. Now, previous design had taken the high ground and put a building right in the center, and I would argue that in this case that was the wrong solution. To occupy the highest, flattest ground on this site with a building was really to deny the relationship to the site that was so necessary to making this an important place to be, with connections to nature and all the things that create the aesthetic attraction that Lance is talking about. So we chose to, at the very beginning in our initial concepts, in fact in our initial integrated design charrette, to think about that edge between the high flat ground and the forested bayhead that you see there illustrated on the left, that's 20 feet below. And by occupying that space, we're able to preserve the high flat ground for outdoor use as a space for gathering and for consilience between all the elements on the site. Second part of the evaluation is lessons learned from Katrina, where we know that healthy ecosystems were mostly healthy tree systems intact, stayed intact during the storm when they were grouped together and they weren't isolated and weakened by influences. And so on this site, of course, the high ground, the flat high ground was impacted through past use. And we found that there were a number of weakened and damaged trees in that area that were quickly removed. And it left this space around which we could build. And only once establishing that sort of relationship to the site do we place the buildings. And the buildings create that edge between the high ground and the sloping topography and the exploration of the site beyond. They take advantage of gathering space and creating these connections. It's arrival, it's the threshold, it's the centering of the space for gathering and then launching out to your next space. Aesthetic attraction comes in at the touch of human beings. I don't think it should be denied. I think as humans we are very much a part of nature, and we should seek that relationship in which what we bring to the table stands out and becomes part of the beauty of the place. I think for us it was asking ourselves, how can we honor this particular woodland and draw people in? How can we create something distinctive and memorable for people when they arrive to make them see things they haven't seen before? And then understanding it for humans and understanding the beauty of a place, it's not about something you observe, it's about something you experience, and you experience through movement in a space. And so what we're thinking about when we're designing this particular project is how to move people down a path, how to cross a boundary, how to gather and center, how to be launched off into a new experience, and how the buildings can support that. And of course you can see these porches that are set up at 21 feet above sea level now fronting the high ground, and it becomes the center and heart of this space where people gather, and I think they love. So the buildings are framing They're orienting. They're allowing us to kind of push through and see these views. You can see this suspension bridge that crosses the forested bayhead and launches you out on this journey to the other side of the site, where you go from lower canopy to mid canopy and upper canopy across your journey as the topography falls away. The buildings are situated along this edge so that it doesn't interrupt natural flows. We used helical piers to touch the ground lightly and allow us to keep the trees intact right up against the buildings, so that we weren't impacting their roots and we weren't clearing areas around the buildings for foundations and sort of damaging those sort of critical root zones and all the issues that relate to the soil erosion and other things that can be the impact of the simple decision about the siting of the building and the foundations we use. And of course, it's all about thinking about these places where can people feel at home, feel comfortable, and sort of stimulated by their environments. The second example I want to show you is a different kind of consilience, and it's at the confluence of the San Antonio River and San Pedro Creek. It's called Confluence Park. It's an underserved part of San Antonio. You wouldn't have thought that, given the sort of forms and sort of gestures that are the part of the product of this place. But the San Antonio River Foundation was really convicted that they needed to bring art and life and ecology and lessons and education to this part of San Antonio that had often been neglected on the south side. And we thought, well, how can we create a space that really honors something different about that place and touches the sky in ways and reaches out to become even more beautiful in the rain than it is in the sun? And thinking about the consilience of geometry, form, and pattern, and the things that that means to us, we gathered around this idea that we could embrace these elements, bring them together around using parametric design as a tool. And we collaborated for the first time ever with an artist and architect, Andrew Cudless, with Matsis out of the Bay Area. And he helped us think about these things. And this is a torus shape that becomes broken down into ultimately into triangles and other self-repeating forms, but at the same time as gesturing towards the use on the site with collecting water and shielding from the sun. Thinking about scale and pattern and self-similarity and the pattern of the pavement that is all related to the geometric forms that we used as to establish this thing. These are abstract geometries that are being applied in ways that are speaking to the way to collect the rain, the way to collect energy from the sun and shield the occupants from the hot summer suns that you find in Houston, and create something that not only is inspiring from the point of view of well, I don't use the word art, but I use the word, the idea of craft and architecture, that these things are made by people, even if it's parametric design and digitally sort of fabricated and sort of constructed off-site using machines and computers. It really, every part of it is imbued with the quality and craft of the human touch from the very beginning to the very end. And I think that's something that really comes through in the beauty of the place when you get to the final result. So for this place, it was about fitting into the site that had been disturbed long ago on the banks of the rivers, collecting sun's energy and collecting rain and storm water. You can see the water flow underneath this bridge to a collection point here on one of the approaches for the structures that change and sort of fit their environment in different ways throughout the day and throughout the seasons. Sort of really just an inspiring and comfortable place to be, a place that's different. A place where you can come and find shelter, where this is a non-air conditioned, non-climate controlled space that is built into the earth, collects sun, but then opens up to the outdoors to allow breeze to flow and sort of daylight in, to flow to the exterior. It's a place of learning. It's a place for play. I think we forget that sometimes. I was Charles Moore's assistant, and before I left him, I asked him, what's your advice to young architects? And he said, thought for a while, which he used to do. He used to think maybe he was going to go to sleep. He would think so long. And he said, don't take yourself so seriously. I was really disappointed. I don't know if he just meant me. I think he meant all architects. I hope. But I was disappointed as a young architect that I didn't understand that. But what I understand now is that he was saying is that don't forget the joy and playfulness in architecture and the opportunity to create that within the spaces in which you work. And so we're happy to see that happening here The connections, again, to geography, to place, to ecology, the lessons that can be learned there, a place for learning, and a place, frankly, to touch the sky in ways that we don't often think about. I mean, how often do we go home at night in the dark? Do we look up and notice the stars above our heads and the clouds in the sky and our environment that's so beautiful all around us and virtually untouched? I think sometimes it takes architecture and that gesture towards those elements, the touch of the human being, to kind of remind us of that. Thank you very much.
So as Lance said, my name is Andrea Love, and I'm a principal at Payette, and I lead our building science group. And I'm an architect. I have a license, but I also was really interested in how the building science and performance could really drive architecture. And so I also got a degree in building science, and have really been trying to kind of fuse this art and performance together in our firm. So for those of you, if you're not familiar, Payette is a 165-person firm located in one office in Boston. And the thing that I think is maybe important to know about us is that we're a specialty firm. We really work in two markets, academic science and healthcare. And I bring this up because that's to say that we design some of the most energy-intensive and resource-intensive buildings out there. And so we really see a particular imperative to making sure that we address their performance, and particularly around energy. So I was going to talk a little bit about how we work, not just in terms of a case study, but sort of how we try to infuse this throughout the practice, and give one case study at the end of how we're trying to do this. And so we really have, the building science group has kind of three things that we work on in the firm generally, which is to lead internal research efforts. We work on all projects across the board, trying to push performance, and then really trying to build what I call an energy literacy in the firm, and trying to push an overall performance and understanding into everyone that is designing our buildings. And so one of the first things that we've really been trying to do is just trying to make performance part of our lexicon. It's part of how we talk about our work. And so every project in our office has an alcove where they pin up kind of working drawings, models, precedent images, whatever it may be. And then there's a little table where we have meetings and project meetings. And so in every alcove, we have the energy use intensity. So that it's always there and always part of our dialogue of understanding what is our target, where are we meeting our 2030 commitment goal? And it just becomes part of how we talk about our work. And I put this slide in to say that I think it's important to remember that we don't work independently. And so we also try to understand who's the best partner to work with. And so we've been taking our 2030 data for our mechanical engineers and trying to understand what's the difference in performance, because I think we're going to make better decisions if we enable teams to understand these things. And so we used to work the most with firm A, and now we're working a lot more with firm D. And so there's a way to kind of shift the firm culture by empowering people with some of the knowledge. And then I would say the most important thing that we do is really trying to integrate into design, to understand how different design decisions start to impact occupant experience. So I apologize, it's a little grainy. But the chart on the left is looking at glare, daylight, peak loads, which has a lot to do with costs and system sizes, as well as energy use intensity, so that we can make these informed decisions. And this is just a simple, and how you present it, I think, is really important, because this is just parametric models that we can run overnight. And then we paired that with rendering, so that as you kind of move these sliders around, you can start to see how different aesthetic decisions impact all these aspects of performance to really make informed decisions. And as I said, the other kind of big thing that the building science group does is lead internal research efforts. We really think it's important because there are a lot of questions that we need to understand that we can't usually solve in the project process, and we see the value in trying to take a step back and understand that. But it doesn't happen solely in the building science group, because we can only do so much, and so we really try to embed it throughout the firm. And I like to say we try to pair the people that have hair with the people that don't have hair, which is to say the people who have a lot of experience and knowledge but not a lot of time, with the people who have a lot of time and enthusiasm but maybe less experience, to really try to maximize the impact. And so over the last 5 years at Payette, we've had 69 staff work on our research projects, so it's really infused throughout the practice. We also solicit, when we first started our research efforts, it really were just all the good ideas I had, which were fantastic, but it turns out other people have good ideas too. And so we now do, annually, we have what we call the research voice. I was going to do Shark Tank, but I'm not very good at pop culture, and so people told me they were really mean on Shark Tank, and the voice, they were much nicer, where they come and they pitch their research ideas, and then we partner them with people in the firm to try to realize them. So some examples of how research is influencing our practice is we were lucky enough about 5 years ago to get a grant from the AIA to do research on thermal bridging. And we went through and we kind of identified common thermal bridges. We went back to a number of our projects. We ran models. We came up with better details. And it's really changed how we design our work now, where we really have maximized the potential and what we learned from that and kind of infused it throughout our practice. And I think the victory that I had was when I came in one day and one of the principals had left this on my desk about this kind of thermal homicide, and he wanted me to write a letter to Architect Magazine about how terrible it was they published this detail. And so it's really about changing the hearts and minds of people. And, the irony is, of course, 4 or 5 years ago, you probably would have designed this detail, but that's okay. And so if anyone is interested, I'm not going to go kind of through this research project, but we do make all of our research available on our website. And so if you have insomnia and you want to read through 120 pages of rainbow color images, I highly recommend it. We also really think that understanding the sort of integrated nature of buildings, so not just the sort of architectural side, but how the architectural side influences and informs mechanical systems, particularly in our project type, I think is really important. And so one of the things that we've been interested in recently, we were really trying to get rid of perimeter heat. It takes a lot of space, it uses energy, it requires maintenance, it costs money. And in the Northeast, if you have a lot of glass, you typically have perimeter heat. But sometimes we were able to get rid of it. And we started off with this naive goal of just trying to create a simple chart that would let us understand what that threshold would be. It was a little more complicated than that, and so we ended up creating this online tool that allows, and mostly because we created that chart and only 2 or 3 people in the firm could actually utilize it, which wasn't a very good design tool. And so what we did is we created this online tool that lets anyone to go in and look at different glazing geometries. So these, in this example here in the little video, it's all 40% glazing. Everyone's meeting the ASHRAE maximum glazing, but just how you compose it has the same U value, can really impact the comfort. And so this is I think a lot of what we try to do is really enable designers to understand the impact of their decisions and kind of infuse that throughout the practice. And this has been having a big impact. So previously, as I said, we were occasionally able to kind of utilize things like triple glazing. But since we released our tool, it's become the default. It's what we have in all of our projects now because we're able to go to both the engineers and our clients and say, here's why it matters. We can show you that, utilizing the latest research out there, we can show that we're going to create a comfortable environment, and it makes more sense to put it in. And we've been lucky enough that a lot of people have been using this tool, so it's been used, as of last year, it's been used in 46 states and 77 countries. So the case study I was going to go through was a project we recently completed for Northeastern University. It's their interdisciplinary science and engineering complex. And it's an architecture that I think is very expressive, but it's a form and a design that's really driven from performance. So we won this project through a design competition. And our renderings and a lot of our concepts, we had some initial ideas about what the performance would be, but it was really this very ambiguous facade. We hadn't quite determined, is it a double facade, or what exactly is it? And a lot of the form is derived from this flow and connection between the other side of campus. This project is the first foray Northeastern had across. There's a Amtrak and commuter rail tracks, and they were trying to expand their campus across. And so there's this bridge that connects, and there's this sort of flow between the two campuses, and that was where a lot of the form came from. And so one of the first things that we did was really trying to understand what was driving the performance. Is it actually about heat loss, because we are in Boston, or is it about the shade, because the main facade is really facing southwest? And what we determined was it was really about the heat gain and the shade, which pointed us towards having a sun shading system as opposed to something else to deal with the solution. So there's a lot of integrative back and forth looking at the performance to maximize or to minimize the peak gains and the solar radiation, because that was really the biggest energy driver for the building. And we integrated that into the energy modeling and with our mechanical engineers, such that we were able to get a 78% reduction in peak gains. And even in lab buildings where they're very internally load driven, the peak radiation is still a big driver in the cooling load. And the reason why I think this integration is really important is because not only does it become expressive of the form, but it also actually allowed us to protect the design intent. Because when the contractor came during construction documents and said, we want to VE a third of the sunshades, we said, okay, well, we'll go back and look at the impact. And so we went back and reran those models, gave that information back to the engineers, who then looked at both the energy impact but also the impact on peak cooling. And it turned out it was actually more expensive to increase the cooling load, the cooling tower, than it was to get rid of the sunshades. And so we ended up being able to kind of keep our original design intent because we really had this integrated process where we'd work together. And I told you that we'd spent a lot of time looking at thermal bridges in our research project, and so we also understood that these catwalks that we're going to have to support that would support the sunshade system could be a big source of thermal bridging. So we spent a lot of time going back and forth with the manufacturer, because they're also a key part of the team, trying to understand how we could support the sun shading system without impacting or minimizing those thermal bridges and not decreasing the thermal performance. And so we ended up coming up with, because a lot of their early designs just had all these kind of knife blades going through that were going to really undermine our thermal performance, was this kind of padded, this rubber pad that braces the curtain wall on either side to take a lot of those lateral loads so that we could really minimize the number of penetrations and get to the performance targets for heat loss that we had. And I just put this example in to show kind of how that research feeds back into our practice. The same design team had designed a few years previously a facade that had a board-formed concrete facade on building. And we'd gone in our research project and looked at it, and we'd found that it had an R4, which wasn't quite what we'd hoped it was going to have. And so we made sure that in the design that we really integrated this modeling in and this thinking to understand how we could kind of embed the insulation, tie it back with kind of some rebar ties, and so that this project, with a very similar kind of board concrete base, was able to get to an R23. We also had this discussion about perimeter heat and the performance. We had set a goal early on of trying to get rid of the perimeter heat, and then, of course, we're not always as integrated as we like, and so we had drawn kind of a double pane piece of glass in our drawings kind of early in design. And so when we got to DD, we realized, well, we don't have the triple glazing that we need, and we don't have the perimeter heat that we're going to need for comfort. So now what do we do? Is we had to go actually through a costing exercise, which was really helpful to understand this cost of what the difference would be. And through some small changes of just kind of increasing the sill height and by a foot, and going to the triple glazing, we were able to create a comfortable environment that was actually significantly cheaper to invest in that triple glazing than it was to add that perimeter heating system. And the form of the building isn't just about the facade, though that's a key expressive part of it. The massing and everything else also really plays into the performance story. And I won't get too much into kind of the particulars of lab buildings, so I'm happy to talk to anyone who wants to geek out at it later. But one of the key parts of this building is an atrium. And it's not just an atrium for the kind of social purposes, though it certainly is heavily utilized for that, because there weren't a lot of spaces like this on the campus. But it is also the lungs of the building. And so what we're able to do, because in lab buildings it's all about trying to minimize the air change rates, we are able to kind of use it as a way to kind of mix and minimize the air. So we deliver air to the offices, it cascades into the atrium. It then is taken back into the lab air handler, where it's delivered to the write-up zones in the lab space and then eventually exhausted from the building with heat recovery. We also have a solar wall that around the penthouse. It turned out it was actually cheaper than typical penthouse screening, and we've been able to get about a 10 to 15 degree temperature rise in the winter off of it, which doesn't seem significant, but in Boston every little bit helps. And it's really, we've been able to kind of really infuse daylight deep into this building. Water was also a key component, and so we have rainwater infiltration throughout the site and capture all the roof water to reuse in the building. Research buildings are also very water intensive as well as energy intensive. And so we were able to get to a 78% reduction over a typical lab building, while infiltrating a good portion of the stormwater on site, really reducing the water and creating an overall better environment, or minimizing the environmental impact. And it's really driven the form and the performance kind of infused together. This is a slide of our average energy usage of our lab buildings over the last 12 years. And we have about 7 or so, give or take. So this is sort of that average of them from the years they're in design. And there's 2 points that I think are interesting related to this. The first point is when there was a real shift in kind of innovation in how we design lab buildings. Again, I'm not going to get into the details, but just understand it was sort of an architectural planning change. But the second one is the one that I think is most interesting, in my very biased opinion, and I think would be interesting to this group, and that is not through an innovation in necessarily design, but in through performance and kind of integrating this performance and understanding in from the beginning of the design. And so the second point is when we signed the 2030 commitment and formed the building science group, and that in each year, bit by bit, we've been able to drive our energy usage down further, not through any kind of big innovation, but learning a bit from the previous project and integrating performance modeling into our design process so that we're really making informed decisions. So that now on average, our average lab building uses 2/3 less energy than they did 10 years ago. And at the same, thank you. And at the same time, our design awards have been going up. So as we drive our energy usage down, our design awards have been going up. And this is just to say that it doesn't have to be either or, but we think it's both.
So Lance, Andrea, Bob have all addressed through the lenses of their practice how beauty and best performance can be integrated. What I want to do is continue this thread, which I've often described as designing holistically. Consilience for me means convergence, bringing everything together at once. The late Bob Venturi, who we used to work for, described designing buildings as making a difficult whole. But so many things that he did in getting to his signature style left so much out on the table and aside to get to that difficult whole. Kieran and I and the firm have really reinterpreted the difficult whole to be more inclusive and to be more and to react to all of the elements holistically that are available to us as designers. Individuals and firms have principles, ethics, and a culture which organizes a process to think, act, react, and pay forward holistic design. How does this happen? It is embedded in our DNA, and it begins at the inception of the firm, really, but it can be grown into other cultures as well, to question, to query, to dig deeply, and to look beyond the superficial. So form for us, can begin with a sketch, of something that begins intuitively at a site, but so often, that sketch for so many others becomes the end result, the form side of Lance's diagram, rather than integrating the performative aspects of it as well. Looking beyond that superficiality, it is really about developing a culture that looks widely, shares widely, and publicly as well. And so, much of what we do, from the inception of a project through to the end, really is about sharing with the profession widely and deeply, whether it's our tools, whether it's our research, whether it's our outcomes. And that's drawn through all phases of a project. They begin with goals, that we constantly are adapting and are drawing that through each of the queries that are brought into each phase of the project. It is supported by an interdisciplinary team embedded into each project. They're working aside our architects, but bringing a wide-ranging series of viewpoints into the convergence of that final whole that becomes the buildings that we make. So, they're deployed, along with our architects, and using a variety of tools and methods and processes, not only to gather and understand data, but to move it beyond the numbers to useful directions. So numbers are numbers, but eventually you have to take those numbers and you have to take that data and you have to synthesize it into something that is meaningful. Then we try to prototype. In this case, the India housing that we're pursuing, really the driver isn't about form, but it really is about the form coming out of trying to reduce the number of elements that we're building with from about 30 down to about 5. and then using those 5 elements and putting that house together for low-income and medium-income families. How do we begin to reduce the energy on this particular building? There's a lot of embodied energy in precast and poured-in-place concrete in order to meet the India knock test. But by shaping the outside walls and the panels, we can reduce the incident solar radiation on that building and incorporate natural ventilation in it so that it becomes affordable and useful to the occupants. We experiment on ourselves. I think architects and scientists don't experiment enough on themselves first. Now, you could argue, well, doctors don't take their own appendix out, but there is a limit to what medicine can do, but not really a limit to what architects can do in terms of really experimenting on ourselves. When we took over a building, which I'll talk about in just a moment, we began with this particular building by completely naturally ventilating the building, but putting 400 sensors in the building so we could understand how it might affect performance, activity, comfort, and productivity. In the context of also getting to beauty, it isn't just simply emerging from that formal data that is gathered or that is discovered, but it also requires the intuitive and subjective circumstantial elements of a project to be discussed and to be synthesized with that data in a discovery process that is open and collaborative and involves collective intelligence. So we then marry that with observable outcomes. These glass studies on our glass test embed, on a variety of projects over the last 20 years, has really tried to understand the relationship between different kinds of layups of glass and their effect on the buildings that we're designing. And we look at those things in a variety of circumstances, both inside our shop and outside our shop. In the case of the New London Embassy, they were up on the roof of the old office so that we could move them around to understand the reflectivity and the solar incidence on that particular glass because of the outcome that we wanted to get from doing that. So it's bringing that collective intelligence, to the outcomes, which is really important, that it's not just a kind of top-down, formal sketch, but really a synthesizing process, across the whole office. I mentioned our office and how that becomes our own test bed and our experimenting on ourselves. The 400 sensors in that office, helped us develop a tool called Roast that we're now sharing, with the design community. It was an outcome of developing Tally that also helped formulate our understanding of this existing building and how a former brewery bottling plant could become a sustainable office building for our platform. As we use the space with those embedded sensors, we continue to understand the activity and the comfort and the productivity of working within those spaces and understanding how that might shape some of the buildings that we do going forward. In several of the Coat Top 10 Award projects that we had that were high-performance buildings, such as the Yale Sculpture Building, the devices deployed essentially reinterpret the form that's in the context on that particular campus, which had evolved from purpose, Gothic structure to being decorative, becoming stylistic, and now cycling back to being something that is, again, performative in the tracery on the sculpture building. And those choices are then deployed around the building in a variety of ways in order to make that building the high-performance building that it is, but being in the context of the middle of the block, it responds to a lot of backs of buildings rather than necessarily being a foregrounded a building on a street. And so therefore it can employ, different, very different aspects that you might find than other might find on the Yale campus. Those same kinds of choices at UCSD, at the Keeling apartments, student apartments, really are about choices and drivers and the relationships of expression that synthesize the context of this student housing project complex, supported by a portion of a campus which is both on an edge but also at a middle. It straddles two different microclimates on this particular Gulf Coast site, and it also had to anticipate future development. So creating a very complex or a compact court arrangement between these buildings, but shaping the buildings and utilizing the materials around the building to help us draw natural ventilation through the building and also self-shade was really part of the form-giving elements of this particular high-performance project. And then there are things that are just simply, total experiments altogether. This wasn't about form, but about how beauty could be derived from the formal expression of the materials and the experiments of an aluminum structure and a polycarbonate substructure, all wrapped by a multi-layered chambered exterior skin called Smart Wrap that it was both an energy gathering device but a way of moving beyond a project at the Cooper Hewitt National Design Museum, but now in a very public forum in the middle of New York City, understanding how that ETFE envelope might begin to help us think about how we might replace standard building materials going forward. And so, this building with 750,000 people walking through it had sensors embedded throughout each of the layers of the envelope, and we took that energy information over 6 months and gathered that and really have a deep understanding of how these more ephemeral materials that lead to a highly recyclable end product, 99% recyclable in the case of this particular house, and off-site constructed, might really change our thinking about how we make buildings in the future. And of course, part of the message here was, can we deliver it quickly? 6 days, 85% onto the site at MoMA in the middle of New York City, and then the last 15% coming in the last 15 days, and then taking the whole thing down and recycling it or storing it for a future deployment in 21 days after the outcome of the exhibition. The last project that you know a little bit about is really about the new London Embassy. A very large project with deep, complex security issues, high environmental impacts, all set in a context that was emerging without really having an appreciation of what everything else around that building might look like. Sitting on the banks of the Thames, really going through a very, very deep formal understanding of both the London context as a whole and the impact of this building on that London context and how form might inform performance, in this really important building that housed 500,000 square feet of office spaces and becomes the symbol of the government in London at the UK. And so getting abundant natural light into this building, controlling glare, having a MOLI variant mechanical system that is highly sustainable in terms of both energy gathering and energy recycling devices. Also, how spaces like landscapes could be brought up through the building so that this highly internalized building can begin to open up back out to the outside, and then how the envelope, which principally had to meet, blast and high security issues first, could still not look like, a dumb box in the context of goofy form London, but really contribute in the context of the London architectural community, a very, very different take on form giving. And so the outer envelope, both an energy gathering and energy shading device, becomes, an opportunity to change, how we think about this building in the emergence of this new neighborhood that's coming along. And so, this very last short video clip just shows you that context and how 25,000 units of housing, all associated along a linear park against the Thames, really respond in very, very different ways than this building, which is situated, due north, south, east, west, in order to, minimize the environmental impact on the mechanical surfaces of that building, and make for a comfortable place to work. So finally, working holistically and consilience is really about the convergence of all these things on our chalkboard. This is architecture. This is science and art coming together. This is the moment when all of these things mean something to the people that use the buildings and interact with what we make. And what comes out of that are often really elegant and well-edited and simple outcomes. Thank you very much.
So I was not very mindful of time in my segment of this, so we're a couple minutes over, but I don't think there's a session in here now, is there? Asking the folks in the back. Okay, great. So I think we'll stick around a few minutes to take some questions if anybody's interested in doing that. I think there are microphones floating around, or they're not microphones, or just yell. The bride's side is a little rowdy, so. Anybody? Thoughts? Do you guys have any thoughts about each other or the audience? Have they been a good audience? Oh, sorry.
Yeah, no, I just had a question for Andrea. You started with building science being a separate unit, but you discovered that it needs to be integrated in order to be fully effective. Is that where you're getting?
Not exactly. So I would still say building science is a separate group. We vary a bit in size, but it's about 4 people in size at the moment. And the building scientists bring a deep expertise in it, but I think we can't be the only expertise. And so there's a certain amount of base knowledge that I think, and empowerment that we try to give to the rest of the firm. So there is still a separate group that's sort of their sole focus, and we work on kind of trying to push those issues and push issues with building performance. But 4 people can only do so much, whereas 165 can do a lot more. And so it's really about using those, I would say using these 4 people to kind of leverage the under 165 to influence all of our work. Mm-hmm.
Over here, sir. And for those of you who didn't hear it, I believe the question was, how can you be so awesome? So the bride's side is particularly appreciative of us. So, anyone else over here?
So you gave a good example with the Sonora Desert cacti. So I was wondering what role biometry you think has to play in this consilience?
Yeah, I mean, did you guys hear that? The question is biomimicry and what role it has to play in consilience, and I'd love everyone else to weigh in on that. But on the one hand, so one of the best things I've ever done professionally was spend a week in Costa Rica with Janine Benyus and her crew, looking at tide pools and making observations about what we can learn about design. And I think that ethic is profound and still, by and large, untapped in our profession. On the other hand, I've also, in recent years, I've become less and less enamored with the jargon du jour, biomimicry, biophilia, et cetera. And I think it's distracting to put a label on a particular thing rather than, as James said, the chalkboard. Well, it's all of it. How do we reach for all of it? The minute we choose one little box and we put a label on it, we put blinders on, right? So I'm sort of more interested in, well, take biomimicry, for example. And during that week, I was there with Kira, who's the person who asked me, well, if architecture is not art, what is it? And one of the questions we asked is, you know, one of the things that Janine says is the biologist at the design table. And I said, what about the other sciences? Is there not a geologist at the design table? So if you're thinking about learning from nature, what Janine is interested in is learning from living systems, but nature is much larger than just living systems. There's someone named Adrian Bajan who teaches at Duke who has what he calls the constructal theory, and he says that physics is really the backbone of nature, not biology. So if you look at a lightning bolt or a cloud or a coastline or a river or your lungs, they all are driven by physical kind of forces that connect the living world with the non-living world. That seems far richer to me than looking narrowly at biology. That's not to undermine what Janine and her people are doing. I'm just saying nature is bigger than life, right? Other thoughts about biomimicry?
If I could just weigh in on that a little bit. 15 years ago, Dave Richards, who's an engineer at Arup, gave me a book while we were doing Middlebury College and live-in hall at the University of Pennsylvania with Arup. And it was entitled Biomimicry, and it was a really, really incredible tome that I think instigated a lot of us to think about, you know, how nature, you know, might inform the things that we're doing. I agree with and concur with what Lance said. I think one of the things that we all try to do is streamline our process to try and get to something that gives us that kind of how can we be, fast and quick about what we do. I think what emerges, like in Bob's work and Andrea's work and Lance's work, you know, being informed by the cactus is really intriguing, but it's not a one-size-fit-all. And I think one of the pleas that you're hearing today is for an architecture of diversity as well, that, you know, derives itself from a variety of, you know, influences, you know, site, context, form, program, environment, and so forth. And that's what gives us a richer, you know, a richer outcome altogether, rather than a kind of classicism, you know, that might come from just simply looking at biomimicry or by some other, you know, singular resource.
Any other thoughts about?
I'll just make one comment. I think that we get hung up on the terms and we get hung up on thinking about how to deliver on the idea, sometimes to the point where we forget the biomimicry and biophilia are really kind of fit together. They're knit together in the same kind of way that some of these other things that we're talking about. And what I love about the discussion is when you think about those intangibles that now we have a language that we've built up around biophilia where we can describe with words things that we've only felt in the past and weren't taught to us in architecture school. So there's a huge amount of value to that and thinking about it holistically, as everybody said. I wanted to say, it's really plugging we received from the Living Futures Institute the award for biophilia, the Stephen Keller Award, just Wednesday night for a project. And one of the comments about the project that I loved, because I really feel this is true, is that it was for Josie Pavilion, some of you may have seen, where we were trying to create a living kind of building on a living landscape on the prairie, but it didn't replicate in visual ways the prairie in any sort of direct translation. And one of the comments for the jurors was it showed that you didn't need to have curbs and interior plants to be biophilic. And I felt like that was true. Really, it's about the systems and underlying order that goes along with those things that matters, and we can learn from that very much.
Yeah, I'll just add to what Bob just said. If you look at biophilia and all the landmark research around it, you know, the designers who are aware of biophilia, by and large, the way they try to incorporate it into their work is they plant some trees, right? Because research shows that we thrive on interacting with living systems. But all that research shows that by and large that what we're responding to often are, as Bob says, the underlying aesthetic principles of trees or living systems. It's geometry, it's pattern, it's color, texture. You can emulate those things in non-living components of design. I'd be much more interested if designers sort of took up the mantle of how do we make all of this feel more like a forest rather than planting a forest in here to try to make this smarter, right? Any other thoughts? No. Oh, over here. The question is where we get our inspiration, specifically people? Where do you guys get? Andrea, who's your hero? Oh, not people. Oh, where do you get your inspiration? I find this carpet particularly inspiring. No one's inspired, I think.
I would say it's a hard question for me because I feel like I get inspiration from so many places. I mean, like firms like, you know, Lake Flato and Karen Timberlake, and there's so many other good firms out there that I think the more we kind of share and learn from each other, the better we're all going to get. There's a group that Lance and I are both part of for the Sustainable Design Leaders, and I always find that incredibly inspiring to see what all the other sustainable design leaders around the country are doing. And it's not to say we go and copy any of that, but I think it's just, to me, it's very inspiring on how I can kind of continue to push our firm. I don't know if that's...
I'll say, this may sound trite, but impassioned clients and stakeholders on projects often inspire me, and it's just so great when we have a client that wants to be involved and they say, this is really important to me and I want to see every part of it. I want to be a part of this whole thing, rather than the ones that say, oh, you're the architect, we trust you, we love what you do, make us happy. And to me, that on one level, that's really very, very inspiring. But there are people, you know, out there. I met Faye Jones. That's why I went to Grace Grad School. When he got the gold medal, I had dinner, and I thought, what makes this guy tick, and why was he so successful? And it changed my life to meet him. And I think about people like Sambo Mockbee, who was bringing architecture to people in the place that they were in a way that was inspiring to me at a pivotal moment. And Glenn Murcutt in Australia, who was bringing this incredible level of craft and detail and attention to the environment, to the work. And more people than you can imagine can be listed, but there's inspiration all around us in every place.
Oh, I knew you were going to hand this to me. She did, yeah. You know, there are just so many influences in our lives, and as we age, there's so many more. I think what really gets me up in the morning, frankly, is not any one thing or any one person, but the fact that architecture has a responsibility to be ethical and sustainable, and that wherever the inspirations come from, that they're through that lens. And so, you know, the people here and in the room inspire me, but in the end, that chalkboard kind of drives, you know, a desire to look beyond, again, what I would call an initial inspiration, or something that might be superficial, that might have been inspired by flying across the country, to something much more deeply profound than that. And I tell students all the time when I'm teaching or when I'm lecturing, I say, the one thing, I know that there are a lot of things I can be influenced by, But I know the one thing that you shouldn't be influenced by when you're designing, and that is, if you're looking in the architecture magazines for your inspiration, it's too late.
So I'll just give a shout out to the person who sort of created the theme of this session, E.O. Wilson, who, and if you're not familiar with him, he's a Harvard biologist who's considered maybe the world's foremost expert on ants. And seemingly in his spare time, he tosses off these other little books that completely transform our thinking about everything. Consilience is a good example. He literally wrote the book on biophilia in the mid-'80s, and so I don't know, he's, in his 90s now, I think? So, I mean, that's someone who has made the most of every bit of time that he's had on Earth, so that's pretty amazing. Any other thoughts as we wrap it up? In the middle here. Why don't we have more engineers and architecture firms? I'm going to punt that to someone else.
I like that question because I've been asked similar questions to that. Why don't you have landscape? Why don't you have, our sustainability director is a mechanical engineer. That was huge in our office, but she doesn't practice mechanical engineering. She helps us monkey architects, be better. But I will say that using a Confluence Park as an example, we had a brilliant structural engineer that wasn't part of our team, but that completely changed and made the way that particular project came out because of his level of thought and sort of interest in the subject, and I think, frankly, our level of appreciation of his presence and role in the project. So I'll say for us, I really like it when we're working with inspired landscape architects that aren't part of our firm, or structural engineers that are from someplace else. And the same with every profession. And so for us, we've chosen to collaborate with different, exciting, interesting people on projects, and that works. It's not to say it doesn't work when you integrate it all, but maybe you could speak to that more than I can.
Sure, I would say we have a similar model. Most of our building science either are architects with a technical degree as well, or engineers that have kind of a design background. So we can bring that kind of fusion, but really just about pushing the firm. And I would say the reason we don't have embedded engineers and a lot of those consultants is because we like to try to find the best one for the job. And we also think working with many different ones, we can kind of learn from all of their good ideas to continue to push us forward. And it's not to say there's anything wrong with the AE model, but we think there's a lot of strength in kind of choosing the right consultant for the job.
So we're getting a very subtle blinking light here that says to wrap it up. So I think we're going to end it there. Thank you all for coming.